Hello everyone, my name is Bai Qiaochu. Today I will talk about the applications of derivatives in three parts. And the first one is about the applications of derivatives in economics. First, cost function and average cost function. The definition is that the cost function is a mathematical function that describes the relationship between the total cost of the production process and the output. Usually, the cost function takes the form CQ equals to FC plus VCQ. We should know that CQ is the total cost and is dependent on the output Q. FC is the fixed cost, which is independent of output. VCQ is the variable cost, which varies with output Q and is usually a function of Q. We can show an example. It is calculating marginal cost. Marginal cost, short for MC, is the derivative of the total cost function with respect to the output Q. It is a function of output Q that MC equals to dCQ divide dQ. One of the example is total cost function. CQ equals to 150 plus 3Q plus 2Q squared. Then the marginal cost function is the derivative of the total cost function. MC equals to 3 plus 4Q. When Q equals to 15, the marginal cost of 3 plus 4 multiply 15 equals to 63. Then the production of 16 units of product cost increase of 63. The second part is average cost function. The definition is the average cost function AC, short for AC, is the average cost per unit of product when producing a certain number of products. It is commonly used to measure production scale and efficiency. By calculating the average cost, companies can calculate the cost of producing each unit of product and thus take more efficient resource allocating and pricing decisions. The formula is assuming the total cost function is CQ, where Q is the number of products produced. The average cost AC can be calculated by the following formula, which is ACQ equals to CQ divide Q. We should know that ACQ is the average cost of producing Q units of product, and CQ is the total cost of producing Q units of product, and Q is the output. The second part is revenue function and average revenue function. The definition is the revenue function describes the total revenue a firm earns from the sale of a product for a given sales volume. It is usually the product of the sales price and the quantity sold. The basic form of the revenue function is RQ equals to PQ multiply Q. We should know that RQ is the total revenue function and represents the total revenue from the sale of Q units of product. PQ is the sales price per unit of product, usually a function of price and quantity sold or market demand. And Q is the number of products sold. We can show an example that which is calculating the revenue function. Suppose firm sells a good and the demand function for the good is PQ equals to 100 minus 3Q, which PQ is the selling price which decreased as the quantity sold. Q increased, and Q is the quantity sold. Then the total revenue RQ is the product of the price PQ and the quantity sold Q, which is RQ equals to PQ multiply Q equals to 100 minus 3Q and multiply Q. Expand the formula. Revenue function RQ equals to 100Q minus 3Q squared. Second part is about average revenue function. The definition is the average revenue function, short for AR, is the revenue generated per unit of product. It is commonly used to measure the level of revenue per unit of product at different sales volumes. Average revenue can help companies understand the trend of revenue per unit of product under different sales quantities. The formula is the average revenue function is the total revenue function RQ divided by the number of units sold Q, which is ARQ equals to RQ divide Q, which ARQ is the average revenue when producing and selling Q units of product, and RQ is the total revenue function that represents the total revenue when selling Q units of product, and Q is the number of products sold. We can show an application and also the third example. We can evaluating the relationship between pricing and demand. By analyzing average revenue, a firm can assess the relationship between price and the quantity sold. In many cases, the average revenue function is related to the demand function. Average revenue can be used to derive the relationship between price and quantity sold, and to help firms understand the market response at different prices. In a perfectly competitive market, average revenue is usually equals to the market price because the revenue per unit of product is the same. In perfectly competitive markets, the relationship between average revenue and the quantity sold and price is more complex. As the quantity sold increase, the price usually decreased, and therefore average revenue changes. So we can show our fourth example, pricing strategy and revenue optimization. Firms can use average revenue to determine the optional pricing strategy. In some markets, the relationship between price and quantity sold is non-linear, and firms can adjust the price to maximize average revenue and total revenue. Especially in monopoly markets, firms have more control over prices, so the average revenue function can help. The third part is about the profit function and average profit function. The function is pi q equals to RQ minus CQ. So we can show our fifth example, finding the output that maximizes profit. To maximize profit, we need to derive the profit function and find its maximum value. So let pi q equals to 90q minus 3q squared. We take the derivative of it and solve the optional yet q by making the derivative equals to 0. And this is the answer. The second part is about average profit function. Definition is the average profit function is the profit earned per unit of product, and it is calculated as follows. APQ equals to pi q divided Q. We can show an application about it. Also, the sixth example, pricing decisions. You can see that it's about firm set pricing strategies based on market demand and production costs, and the average profit function can help firms determine the relationship between price and output, especially in imperfectly competitive markets. And the seventh example is about cost control and economics of scale. By analyzing average profits, a firm can determine the reasonableness of the scale of production. If the scale of production is too small, the cost per unit of product may be higher. Okay, the second part is about Washer's method. You can see that this is an example. We can calculate in Washer's method, which is V equals to pi in derivative from 0 to 3 R out square minus R in square and dx. You can see the answer. The third part is about moment and center of mass. The definition is a moment is a measure of the rotational effect of a force on an x. Simply put, moment describes the ability of a force to rotate an object. Formula is m equals to F multiply R multiply sine theta. Second part is center of mass, and this is the definition. We can show an example that suppose a uniform object such as a simple wooden pole. Okay, we can see the relationship between the center of mass and the moment. If the force exerted on the pole does not pass through the center of mass. The center of mass is subject to a moment that causes the pole to rotate. If the force is applied through the center of mass, then the pole will move directly in a straight line without rotating. Okay, that's all. Thanks for your watching.